Hey, hello, geometry friends. Welcome to chapter 6. Here we go. Hope you had a nice break. We're going to be jumping right back in. And this is 6.1 on polygons, um, our many-sided, shapely friends. So let's jump in. We got a number of definitions and then just 2 questions to cover in the notes. And again, encouragement, fresh start, new notebook grade, new year. So let's jump right in and again, do your very best in terms of your neatness, your diagrams, completeness, and all that. Alrighty, here we go. So our first definition is the whole focus of the chapter, and that is a polygon. So what is a polygon? A polygon is a closed figure of 3 or more sides. Okay, so again, with only 2 sides, you can't draw any sort of shape, but once you add that third side, you can have the most basic polygon, or at least the least sided polygon, the triangle. Then you add 4, now you have a quadrilateral, and on to 5. Now you can have what's called a pentagon, and on and on. And on page 382, you can see the names of all the different types of polygons based on the number of sides. So that's what I want to add here. It's based on or named by the number of sides. A couple other things to keep in mind. So we'll just draw our most basic. Okay, so let me be more precise. There's a polygon right there. The segments of a polygon can only intersect with 2 others at their endpoint. So for example, you can't have a polygon. Actually, first I want this word close. So first of all, if it doesn't close, like there's a gap, that's not going to be a polygon. In fact, let me do it this way. A couple things that aren't polygons. If it doesn't close, if they intersect not at the endpoint, that's going to be a problem. And if they, let's see, if we do something like this. Let me draw that better. Oops. If they intersect at anywhere other than the endpoint. So if you notice here, this line right here, they're intersecting here, not only at the endpoints. Another way of saying that is they just can't cross each other. You also cannot have a, no curves. Let me see if I write that. No curves. Okay, so you're not going to have a polygon that looks something like a circle. A circle is not a polygon, nor is some combination of that if you have straight sides within a curved side. So all of these right here are not polygons. Okay, they have to be closed, they have to hit at the endpoints, they cannot cross, and they can't have curves. And again, they're classified by the number of sides. So let's keep going. What does it mean when we have a regular polygon? Well, a regular polygon is a polygon whose sides and angles are all congruent. So for example, well, probably the easiest would be something like, trying to actually draw this correctly. Let's see, 1, 2, 3. Right there. So that's a regular polygon because you've got all 4 sides are the same length and all 4 angles are the same angle. Okay, or you could have something, and this probably won't be perfect. Excuse me. Well, I could do it this way. If you had an equilateral triangle, that would be all congruent sides, all 60-degree angles. So these are regular. Something like what I drew above, you have something like that, that is what we would call irregular. Okay, because the different sides and angles, still a polygon, but it's an irregular polygon. Okay, and you'll see that comes in to be very useful when we're going to be later calculating the lengths of sides and the amount of angles. Okay, so now we need to compare convex versus concave polygons. Okay, and so a concave is a polygon where a diagonal intersects one of the sides. So now at first that might sound confusing, but let's go ahead and just illustrate it. So say I have a polygon that looks something like this. Okay, it's irregular. It's not all congruent sides and angles. It is closed. And when we say a diagonal, what we mean is if I were to take any vertex and connect it to any other vertex, am I intersecting one of the sides? No. I can go from corner to corner in all these cases, and I'm not intersecting any of the sides. So this would not be concave. However, if we drew one like this, kind of like the one I actually just drew above, say we drew, okay, that is in fact a polygon. Now what happens if I try to connect all the diagonals? I could do that, I could do that, or the vertices. Say I do this, okay, and you can see there I move outside the polygon. And so this would not be this would be concave. Basically, the way I understand this is anytime it looks like it kind of has a, what I would call, an indent. The polygon is indented in any way. Like for example, this one's out of our book. Okay, that would be a convex polygon. I'm sorry, concave polygon, because you can connect the diagonals and you go outside of the polygon. Okay, so convex is the opposite. It's a polygon where no diagonals intersect the sides, and that's just, again, just like the ones I drew, where it does, none of the sides are kind of indented, but also in connecting any of the diagonals, I'm never crossing the sides of the polygon or going outside of the polygon. Okay, so that's convex, and I usually try to remember this as, think of a cave as something that has a hole, a cave you go into, and so anytime the shape seems to have a kind of an indent into it, that's going to be concave, and then the other one is convex. Okay, two more definitions. We have the polygon sum theorem. This is basically tells us how to find what all of the angles inside of a polygon add up to. And so that is the sum of all the interior, that's really important, these are the inside angles, of a polygon can be found with this formula, n minus 2 times 180, where n is the number of sides. So let's go to, I'll show you, we can apply this to something we already know. We know that all of the angles inside a triangle have to add up to 180. So if you have a triangle, okay, n would equal 3 because you have 3 sides, okay? And so you would plug that in and you'd say 3 minus 2 times 180. Well, that's just going to be 1 times 180. And so all of those angles add up to 180. If we did something like a rectangle, okay, now if you know that, a rectangle has all 90-degree angles. So we can kind of know 90 plus 90 plus 90 plus 90 is 360. But let's check it with the formula in this case. So n equals 4, because I have 4 sides. So it would simply be, it would simply be 4 minus 2 times 180, or 2 times 180, which is going to equal 360. Okay? And so when you get into something like this, and you need to find out, okay, what do all these angles inside add up to? Well, count the sides. 1, 2, 3, 4, 5, 6. Okay, so this is an irregular hexagon. So that means we're going to need to go n is equal to 6, and then we can plug that in. 6 minus 2 times 180. Sorry, kind of cramming this in the side of the screen. Alrighty, and it tells you again what the sum of all the angles inside add up to. And then we have a polygon exterior angle theorem. So in other words, what do all the exterior angles add up to? And just before I say that, a reminder, an exterior angle is made by extending one of the sides. So in other words, when we say exterior angles, we are saying that all of these angles that I've just created, I'm going to mark them in blue, what do all these angles add up to on the exterior? Okay, and the easy thing to remember about this is it is always 360 degrees. So whether I'm drawing a 1, 2, 3, 4, 5 pentagon, or whether I have a triangle, okay, and I've got my exterior angles here, or even if you've got a more complicated shape, okay, you got all of these angles, they're all the exterior angles. Okay, all of these, in all cases, they're going to add up to 360. And what's interesting, you can see, is because what happens is basically the exterior angles of a polygon form a circle. And so that they're always going to be slowly, in other words, if you were to keep drawing polygons and keep adding on sides, and what happened is the length of the sides would get smaller and smaller, and you get closer to a perfect circle and a full 360 degrees. You can also see that the bigger the shape, the fewer the sides of the shape, the larger the angles. And so anyway, as you add more sides, you're adding more angles, but they're getting smaller and smaller. So the sum total of 360 is always going to be the same. Okay, so this is 360 for all those angles. Okay, and in the questions, I'll show you how to apply this, especially to regular polygons. So just keep in mind, the interior angles, they increase. The number of sides -2 times 180, and so that will grow. The amount of the exterior angles, though, however, will always be 360. Okay, let's look at our two questions. So question number 1 is find the total sum of the interior angles of a regular octagon and a single angle. Now, so let me just point out, we'll just find the sum first. So the sum is found by doing our whole n minus 2 times 180. Okay, and in an octagon, that means we have 8 sides. So we're going to do 8 minus 2 equals 180. I'll just put n equals 8. So we're really going to go 6 times 180. Alrighty, and so what's 6 times 180? Well, that's, what is that, 360s? And so we'll just calculate it. 6 times 180. For all you snowboarders out there, or skateboarders, that's a 1080. So 1080 degrees. So that means within this shape, all these angles here, they add up to this 1080 degrees. Okay, so I know the total. Now, what's interesting to answer the second question is, what's a single angle? In other words, what's just one of the angles? Well, if this was irregular, we couldn't answer that because we don't know how the angles compare. But because this is a regular, which means all the angles and all the sides are congruent, I know that I have 1080 degrees of total angles spread out over how many angles? It's always equal to the same number of sides. 8 sides, there must be 8 angles. So that means I can calculate one single angle by doing the total amount of degrees divided by the number of sides. Okay? So in other words, to find the single angle of a regular polygon, has to be regular, it's always going to be the total, or I'll say the angle total divided by n, which is our number of sides. So in this case, I do 1080 divided by 8, and I get that it is 135 degrees. So each of these little angles here, which you can see they're all up 2, so my answer makes sense. Each of those are 135 degrees for a total of 1080. So again, use the formula to find the total, and if it's regular and you need to find one angle, you just divide by the number of sides. Okay, in number 2, we're going to do again with an octagon, but we're going to do the exterior. Okay, so this, actually I'll go ahead and just redraw it real quick. So we've got a regular, so it's a little sloppy. So there's but now there's my octagon, but now I want to find what's the sum of all these exterior angles here on the outside. Okay, well, this is even easier in that I know what the total is. The total is always the same. It's always approaching a perfect circle. The total is 360 degrees. Boom. That's done. Like it ain't no thing. Okay, super easy. Now, what is each of those individual angles? Well, there's 2 ways to find this. The simplest, well, I won't say the simplest, the one immediate way is to say, okay, well, if the total, just like we did above, if the total's 360 and there's 8 angles, because it's an octagon, then that means I can just take my 360 and I can divide by the number of sides. So I'll just take the total number of degrees and divide by the number of sides. So 360 divided by 8 is 45. So that means each of those little angles, which are quite acute, must be 45 degrees. Okay? A second method, just to show you, is look right here. I got 135 for the inside angle, and I got 45 for the outside angle. Each of these right here are supplementary, right? Whether it are here and here. So that means if the inside one is 135 and I want to know the outside one, I can just do 180 minus 135. And I can see that is in fact 45 degrees. So there's another way to find, if you know the interior angle, sorry, my picture's in the way. If you know the interior angle, you can just subtract it from 180 and you know the exterior. Or if you know the exterior angle, you can just subtract from 180 and find the interior. Because an interior and exterior angle will always add up to 180, always be supplementary. Alrighty, welcome to the world of polygons, angles, interior angles theorem, exterior angle theorem, and also knowing your definitions of your different polygons, and starting to learn the names of the different sides: quadrilateral, pentagon, heptagon, octagon, dodecagon, all that good stuff. All right, it's going to be a fun chapter. Bring your questions, and we'll have a good time. Talk to you soon.